Welcome to the Transum Podcast, a monthly roundup of the new features on the transum.org website, providing mathematical puzzles, games, learning activities, and the ever-popular mathematics lesson starter of the day. Here's your host, John Tranter.
Hello and welcome to podcast number 138 for the month of May 2026. And let's waste no time and get on with the puzzle of the month.
King Arthur is organizing a knight's quiz night for 5 of his most enthusiastic knights. He has set 11 chairs, labeled A to K, at his round table. Knight 1 sits in chair A, but the other knights are wondering where they should sit according to the king's rules. Direct the other 4 knights to the remaining chairs so that all of the following rules are obeyed. Knight 1 has other knights sitting 1 chair clockwise and 1 chair anti-clockwise away. Knight 2 has other knights sitting 2 chairs clockwise and 2 chairs anti-clockwise away, and so on. Where should the 5 knights sit?
That's the Transum puzzle for this month. The challenge is set. Have a think, make a plan. You have 1 month to figure it out. Send in your solution as soon as you can.
Okay, so draw yourself a little diagram and get figuring out where those 5 knights should sit on those 11 chairs around the round table. And if that's too easy for you, think about 6 knights and 13 chairs as an extension. Oh, there's no end to the possibilities for this puzzle. But anyway, if you get an answer to the original puzzle, please send me an email to podcast@transum.org. I would love to hear from you. So while you're thinking about that, here are some of the resources either updated or added to the Transum website during the last month. Hidden quadratics. You may remember last month I talked about using AI Claude Cowork to analyze hundreds of past exam papers on my hard drive to find examples of hidden quadratics questions. So that was so that I could develop this exercise in 3 levels where students get to spot the quadratic hidden inside exponential, trigonometric or fractional equations. The final challenge is a real-life word problem that requires them to set up the equation themselves. So the whole thing is self-marking, of course, with optional hints. So it's perfect for independent revision or a quick consolidation session. Okay, an old activity called Snake Sort has been updated and given a new dimension because a hidden snake can now disappear from the collection, turning a straightforward sorting task into a simple but engaging game of deduction. So there's a purpose for sorting the snakes because it helps you identify the snake that's missing. So have a look at that. It's called Snake Sort. And all the things I talk about in this podcast, you can find the links to in the web version, the newsletter, which is basically the same as this podcast, but in text. Don's Expressions is a new algebra exercise that was originally created by the late and much missed Don Stewart. It's all about getting students to read line diagrams and turn them into algebraic expressions. Each question shows a set of horizontal bars stacked on top of each other, lined up against a dashed guideline. The top bars are labelled with numbers or with expressions like x, 2x, x plus 4 and so on, and underneath are some mystery bars labelled A, B and C, and the job is to work out the lengths of each of the mystery bars in terms of x and numbers, and of course simplify them as well. You get the idea. So it's a new way of creating expressions. Pyramidenstumpf. That's meant to be a German word, and I've no idea how you pronounce it. But it is a great word, And it was the subject of the first email I had received from Alan for a couple of months. Now, Alan teaches in Germany and often lets me know if something in the curriculum seems unfamiliar or someone educated in the English system won't have come across before. I, too, had never seen the formula that he sent me. It's for the frustum of a pyramid. So, after convincing myself that the formula is the equivalent to the one I use, the subtract the volume of the virtual chopped off smaller pyramid from the volume of the virtual big pyramid in order to get the volume of the frustum. So, interesting formula. Not seen it before. Have a look in the newsletter if you want to see the diagram that goes with it. But it is h over 3 lots of a1 squared plus a1a2 plus a2 squared, where a1 is the width of the base and a2 is the width of the square created when the top's chopped off, if you can imagine it like that. Oh, there's also a formula for the frustum of a cone given in the German textbook. So again, I've linked that in the newsletter, transom.org/newsletter. Hey, guess what? Netflix contacted me last month seeking permission to use Equatro on a South Korean reality game called The Devil's Plan. So in the program, contestants play both collaborative and competitive strategy games in order to win a cash prize. Now, I don't know what episode it's going to be on, and I don't think I've got access to it here, but if you do spot Transom on the telly, please let me know. Now, one phrase I've been thinking about recently, because it's being used in the news, is a realistically possible. If something is realistically possible, that's used in news reports. And it sounds meaningful, but I wonder how many people could actually turn it into a number on a probability scale. And that thought stayed with me, so I was interested to hear an episode of BBC Radio 4's More or Less programme or podcast, looking at the language people use when talking about chance or uncertainty. And in the programme, researcher Adam Kucharski explores the rather slippery words often used in the media, such as likely, possible, and similar expressions. And he talks about a quiz that he created to find out how different people interpret these phrases. And the results just show how varied these interpretations can be. So what sounds clear to one person may suggest a very different probability to someone else. It's a good reminder that words about chance are not always as precise as they first appear. And I'm leading to the fact that if this topic does interest you and you want to involve your class in the discussion, you might like to explore the 3 related Transom activities: probability words, probability washing line, and likelihood. So you'll find those all by searching the Transom website, or go to the newsletter and you'll find the links that I've placed there. Good luck to all those taking exams in May, by the way. May. There may still be some time for some last-minute exam question practice, of course, on the Transom website. And have you read my favourite exam tips, I wonder? Well, now's a good time. The link is in the newsletter, and it's presented in the form of a poem. So, the Transom subscribers have been recently surveyed to see which courses they teach and which age groups they teach. And I've put some interesting pie charts in the newsletter showing some, unusual comparisons, I think. I asked, do they teach GCSE or IGCSE? And I was surprised to find that the number teaching IGCSE outnumbers the GCSE teachers by 2 to 1. Then I asked about IB Diploma and A-Level. And it's roughly split down the middle, but there's definitely a larger cohort teaching IB Diploma than A-Level. So these are just teachers subscribed to Transom, by the way. And then the age groups, well, the biggest age group is 11 to 13, followed by 14 to 16. So that's roughly where most of the subscribers sit in terms of how old their students are. Okay, finally, the answer to last month's puzzle, which was...
Quasmere quadrant has straight edges of length 24 metres. Inside the quadrant, an orange orchard is shaped like a semicircle, with its diameter lying along one of the quadrant's straight edges and of the same length. What would be the maximum possible radius of the green glade, which is also a semicircle with its diameter along the other straight edge of the quadrant, if it touches, but does not overlap, the orange orchard?
Now the answer is 8 metres. But don't leave it there. Please have a look online, transom.org/newsletter, at the variety of solution methods shared by Transom users around the world. I really enjoyed reading about how the problem can be solved in different ways. So have a look at responses from Scotland, New Zealand, the US, England, Germany, and unusually 3 sets of student solutions from a maths club in the UK where students worked in pairs but with a student from a different year group, a different age. Have a look at that. I think that's quite interesting as well.
Then the puzzle's been solved. The mystery ends. There's nothing too hard for Transom's great friends.
Okay, I think we're there. That's all for this month. Don't forget to solve the puzzle of the month if you can and let me know. podcast@transom.org. And remember that to avoid doing calculus while you're thirsty, because you may have heard the warning, don't drink and derive.
Thank you for downloading and listening to the Transom podcast. You can find the website at www.transom.org, where you're welcome to use all of the activities absolutely free, or jump in with both feet and become a Transom subscriber.